Testing is definitely something we should be doing more of. So in this video, I'm going to show you how easy it is to get set up with Vitest. And I'm not only going to show you how to do unit test, but I'm also going to show you how to do integration test and end-to-end test, as well as how to work inside of a browser environment, as well as with React, and how you can set up Vitest even if you're not using a Vite project. This is going to cover all the setup steps as well as in-depth how everything inside of Vite works. So this is a masterclass on everything you need to know about testing with Vitest. Welcome back to WebDevSimplified. My name is Kyle and my job is to simplify the web for you so you can start building your dream projects sooner. And getting started with Vitest if you're using a Vite project is incredibly easy because all you need to do is just install the library just like this and you already have Vitest working inside your project. It's a little bit more complicated if you're not in a Vite project. We'll get to that later in the video, but if you're in a Vite project, it's incredibly easy to get started with. And the nice thing is you can just go to this StackBlitz demo that's on their documentation page and use Vitest in the browser without even having to download or install anything, so you can play around with it without dealing with the configuration issues. Now, if you are deciding to install Vitest into a project that doesn't normally use Vite, one common error that you may run into is if you're using TypeScript for different import paths and so on, you might run into some issues about finding particular paths. Just make sure you use this tsconfig paths plugin and add that in when we get to the installation steps, and that'll make it work for TypeScript. And I'll show you how that works because I've actually done that in our application. Now, the application we're going to be testing is very basic. It's just essentially a simple counter application. We increment here, it counts up this, and we have a sum function that just adds this count to itself. So essentially it doubles it. So this is just a very simple React application that we can use for our testing while we go more in depth on how everything inside of Vitest works. Now, if we take a look at the code for this example, I'm mostly using the boilerplate code for a Vite application inside of React. Normally this Vite config file looks like this when you first set up a React application. So it's pretty much the boilerplate. The only thing I added was that tsconfig paths file or plugin that I talked about, and that's because I want to emulate what it'll look like if maybe you're not using Vite and you have some type of import aliases inside of TypeScript. For example, here I have this import alias so that inside of my code, for example, this counter component here, I can import using this @alias syntax. That's not built into normal Vite. It doesn't actually read this tsconfig. So if you add this in, it'll make it so that this Vite config file can actually read properly from TypeScript. And oftentimes if you're using some other bundler that's not Vite, you're going to have your stuff written in TypeScript and not in Vite. So you just need to make sure that you import this particular plugin if you have that particular situation. Now again, if you're using a Vite application, all we need to do is just run the command to install Vitest. So we can come in here, npm i-d, and we can get Vitest. Make sure I spell that properly. There we go. And that'll install Vitest into our project, and we pretty much are completely good to go. In our package JSON, we'll just add a script for testing, and that's all we need to do. Now, if you're not inside of a Vite project, all you need to do is to create a config for Vitest. So instead of this Vite config, you would create your very own Vitest config, just like this, and that'll essentially do the same thing for you. You just want to make sure that this Vitest config works with whatever framework you're in. So if you're using React, make sure you get the React plugin and so on. Now, in our case, we're using Vite, so I'm just going to rename this back to a Vite config since we are inside of Vite, but that's how you would work if you weren't inside of Vite. Now we can go to our package JSON and actually set up the code for running this. So inside of here, we have a bunch of packages or a bunch of scripts. We can write our very own test script, and that test script can just run Vitest, and that's going to run all the tests inside of our application. And if you want to watch, you can just add the -- watch flag, and that's going to watch for any changes. So that'll just automatically rerun your test. Depending on your use case and the size of your test suite, you may or may want to enable this particular feature. But I can come in here, and if I just run test, you'll see that we're probably going to get some form of error because we don't have any test. You can see no test files found, so we need to add some test. Now inside of Vitest, if you've ever worked with a testing framework like Jest before, or even if you've worked with Chai, there's a lot of similarities between these that make it really easy to work with. So to create a test file, all you need to do is just create a file that ends in .test. Whatever the extension is. So if we wanted to test this sum function, which is a really great starting point for us, we can come in here and we can create a file called sum.test.ts. And it can be either .test or .spec. It doesn't matter. They will both count as test files. I'm just going to use .test because that's the naming I particularly like. Now immediately you can see here that it's saying that we have one failure for this test file, and that's because we have no test in this file to actually run. So obviously that's why it's failing. So to create a test inside of Vitest, there's a few different ways we can do it. First of all, you can just use the function test, and we need to make sure that we import this properly. So we can come up here, we can import test from Vitest, just like that. And what this allows us to do is define a function with a name. So we can come in here, we can give it a name. So we can just say test sum, and then we pass it a function, and this function will be doing all of our different testing related code inside of here. Now, one other thing you can do is if you don't like the name test, you can use the function it instead. It and test are both exactly the same thing. They both do the same, they're just aliases for each other. So they're both exactly the same thing. It's entirely personal preference which one you want to use. I'll just use test because it's a little bit more self-explanatory for this video. Now inside of here, we have the ability to expect certain things or certain things are going to happen. So generally you're going to write the word expect like this, which comes from Vitest, and we're going to pass in some value. So let's say that we're going to be passing that we want to expect the sum function to do something. So we're going to say in here, we expect the sum of 1 and 2 to be a particular value. So let's just make sure we import sum just like that. And we want this to be a particular value, so we can use a bunch of different assertions. You can see there are a ton of assertions inside of here. I'm not going to be able to go over every single one in this video, but there is really great documentation covering all of these. And that documentation can be found right here in this expect category. If we scroll through, you can see, I mean, it's just a massive amount of text inside of this document. And if I zoom my screen out a little bit, move my camera out of the way, you can see on the right-hand side, it lists all the different things that you can do. For the most part, they're relatively self-explanatory, like to be, not to be, and so on. But I don't have time to be able to cover what every single one of these does, so I'm just going to be covering some of the more basic ones that you're going to be using, as well as showing you how to use Vitest in general. So now let's go back to our test, and you can see here that we can use that to be, because that essentially says we expect one thing to be the same as another, and we can just use to be less than or to be greater than. In our case, we want to be, or you can say to equal. Both of them are going to be the same in this particular use case, but there are minor differences between them. The big difference if I hover over here is that to equal is working kind of like recursively. So if you use this on two different objects and they both have the same shape, this should work fine, while to be expects the same reference. So it must be the exact same object, for example. When we're just comparing numbers though, it doesn't really matter which we use. So in our case, we'll just say to be 3. So we expect the sum of 1 and 2 to be equal to 3. If I give that a save, you can see we get that one passing test, which is great. Now, if there was an error inside of my code, for example, I did minus here instead of plus, you'll see when I save, I get this nice error. And if I just bring this up a little bit bigger, you can see I get a really nice warning. Essentially expected -1 to be 3, object.is equality. And you can see here expected received, and it shows me I received 3 and I expected 3, sorry, and I received -1. So this is a really great way for me to be able to like, okay, what did I get? What is the result actually showing for me? And so on. So it's a great way to see exactly what failed, when it failed, and it's really nice. Also, if we go back to our test here, when you're writing your test, it's important that you always put the thing you want to test in the expect section and the thing you want it to be equal to in this to section. That just makes it so when your code actually prints out errors, it prints out a logical error. You can see expected, the value of 3, received -1. If I flip-flopped these, I put the 3 here and I put the sum over here, my error is going to be flip-flopped. You can see it's expected -1 and received 3. So just make sure that when you're writing your test, the expect category is always where the function that you're calling or whatever you're testing goes, and the to section at the end is where you're testing to see if this thing is equal to a value or something like that. So that's pretty much the most basic test that you could make with Vitest. But one thing that's really important is that oftentimes when you have larger code bases, you want to group your tests together into different categories. For example, all the tests for this sum file, I may want to group into their own category for that, or maybe I have multiple different categories that I want to test for different behaviors. The way you can do that is with a describe block. A describe block is essentially a way to create a wrapper around different tests that allows you to group them essentially all under one name. So I can say that this is going to be describing basic sum usage. There we go. It doesn't really matter what the name is. This function is so simple, it may not make sense to have describe blocks. But now essentially I've wrapped this test in this describe block and it gave me a name for this particular category. So when I run my test and if I get a failure, you can see that I get different information about what that actual test was that failed. So if I come up here, you can see basic sum usage, running test sum, you can see that I get the error right there. So it gives me a little bit more hierarchy in what my different tests look like. And if I just come out here with another describe block, and we'll call this one advanced sum usage, and we'll call this sum 2, something like that. And then I'll create another test just on its own. There we go. So now we can actually see what that looks like inside of our testing suite. We scroll that up. Make sure I get all the way to the top here because we have a bunch of failures. You can now see I have basic sum usage with that one test, advanced sum usage with another one, and then this one's on its own. So it gives me a little bit of extra hierarchy, which is really nice. Now, one thing that some people like to do, I generally don't do, but it's really up to personal preference what you want, is they may not like having to import Vitest into every single one of their testing files. They just want to have this describe and this test block and everything be available for them globally. This is actually something that you can do inside of Vite. If we go into our Vite config here, there's an option for test. You'll notice I don't get any TypeScript autocomplete for this right away, but I can fix this problem. If I just look at the documentation, you can see there's a section right here that essentially asks us to copy paste this reference in here. This is just adding TypeScript types for this particular thing. So we can copy over this reference and we can bring it into our code. We just need to make sure we put this directly above the import right here for our defined config. That'll give us the import for this. So now we have all of our type information for test, and inside of here you'll find a globals section. If we just set this to true, that means that all of these things that you normally import from Vitest are going to be globally available. So if I get rid of this and I just make sure my test actually pass, so let's fix our sum function so our test will pass, you can see when I say if we get passing test down here, all of our tests are passing, but now again I'm getting TypeScript errors because these things, they don't know what they are. Now again, we can rather easily fix this in TypeScript. If we go to our TypeScript config, we just need to add a section for types. So we'll do that down here. We can say types and we can put our Vitest globals directly in there. Now by saving our file, coming back here, you can see that cleaned up all of our TypeScript errors and we get nice type safety for everything. Now, whichever way you do this is entirely personal preference. Like I said, I prefer to not use globals and just import everything manually because I find that's a little bit easier to work with. But if you don't like doing that import, you can do this global way as well. They both work exactly the same. Now, another interesting thing about test is we can actually pass in some configuration options here as a second parameter that allow us to more finely tune how these different tests work. For example, we could specify a test as skip true, and it's just going to skip this test. So down here, you'll now see that we have 2 passing tests and 1 that was skipped. We can also mark a test as to do, and essentially that says that we need to still implement this test. It's really great if you have just like an empty test that you want to say, hey, I want to write a test for this, but I don't want to do it yet. You can put that to do in there as a reminder to come back to that particular section. We can come in here and look at more options. You can see fails right here. If we set that to true, it's essentially always going to fail that test no matter what. May be useful for certain situations. And one thing that I actually really like is this only option right here. If we pass this as true, it'll run just this test and none of your other tests. This is really useful when you're debugging a particular test in a very large suite of tests. You may just want to test that one test. You can just come in here, throw an only true on there, and now it's going to run just that one test, which makes it easier to test a large code base. Now, there are a few more configuration options, but they're not all super useful. So for now, we're just going to move on. And I also mentioned that up here in describe, you can do the exact same thing with actually even more configuration options. As you can see, we have tons of different configuration options up here that are pretty similar to what we can do inside of test. So it allows us to configure which tests we run, when we run, and so on. Now, the next thing I want to talk about is how you can configure your test to run certain code before, after, during, and so on. There's a bunch of different things that we can import from Vitest, such as after each, before each, that allow us to run specific pieces of code before our test, after our test, and overall it makes working with more complex tests a lot easier. So I can just come in here and I can say that I want to do a before each, just like that. And what this is going to do is it's going to run this particular piece of code, whatever function I pass into here, before every single one of my tests. So if I just put a simple console log that says hi inside of here, and now I look at my console output, we should see I get hi printed out 3 times, once before each one of my tests. And it even tells me exactly which test was run and the standard output for that test. So you can see I'm getting this run before every single test. I can also come in here with an after each, which is essentially the exact same thing, but it runs after my test. So I can put a by inside of here, and now you can see it's running hi by for that first test, hi by for the second test, and hi by for the third test. So again, it's running before and then after each one of my tests in turn. I also have the before all and the after all, and this is very similar to before each and after each, but instead of running before each test, it runs before all my tests, and same thing with after, it runs after all of my tests are done running. So we should see here, we just have hi and by being printed out one time because it's running before all of my tests and then after all my tests. Now, the important thing to note about these before all, after all, before each, and after each is that they are scoped to the particular block that they're inside of. So they're scoped to the describe block that they're a part of. Now, in this case, these ones are global. They're not inside of any describe block, so they will run before all of our tests and after all of our tests. But if we were to come and move this inside of, for example, basic sum usage, and we remove it from here, just like that, this is going to be inside this basic sum usage. And let's add one more test into there. So we'll have 2 tests inside of here, and we'll just have 1 test out here on its own. What's going to happen is this before all and after all is going to run before these 2 tests and after these 2 tests, but it's not going to run before or after this particular test. So if we give that a quick save and we scroll up, you can see that I'm getting hi being printed out here and by being printed out, but it's only for these 2 tests. I can even show you that by just saying console.log. This is going to be test sum, and we'll just copy that down so it's in every single section. So this is sum 2. And then this one is the on its own. There we go. So now if we look at it, you can see I get hi being printed out before test, sum, and sum2. Then I get by being printed out because it's after all of those tests. And then finally this test down here runs. So that's another really important use case for these describe blocks, is it allows you to create these before and after hooks that are going to run before or after some of your tests, all your tests, each of your tests, to make it so you can have certain blocks for setting up particular things inside of your code. For example, this can like set up a database connection or something that you need to do to make everything inside of your function work for your test. All of this setup can be done here. And then once you're done, you can do all your teardown for like closing your database connection, all that different stuff. So all of this can be handled inside these blocks, which is really useful, which is another great use case for describe. And you can even nest multiple describes inside of each other to get really nested and labeled super well and have fine-tuned granularity on what exactly is happening at each one of your tests. Now, something else you can do in Vitest that's only tangentially related to testing is benchmarking. And this is something that you have to configure since it's currently an experimental feature. So we can come in here with benchmark and set that to an object. And in here, we can configure all the different things we want, such as which files to include, which to exclude, and so on. So this allows us to fine tune what our output and input looks like for the files that we're going to be benchmarking. Now, by default, any file that has .bench in the name, so we can come in here, sum.bench.ts, allows us to run a benchmark. So what we want to do to run a benchmark is we want to use this bench function. Works very similar to test, and we'll just call this sum bench mark. We pass it a function, and then we just run some code inside of here. So let's just call the sum function with 1 and 2 being passed into it. And this is how we create a benchmark. Now to run a benchmark, all we need to do, I'll just copy this code over, and we'll just call Vitest, and we're going to pass in the bench option, and we'll make sure that we are watching that. Give that a quick save, and we can call this benchmark instead. And now I can run benchmark, and it should run all my benchmarks inside my code. Now I gave it a little bit of time to run because it takes a few seconds to run your benchmarks to make sure they're efficient, but you can see I get a bunch of information about how quick this particular function was, all the different things related to it. So if you have performance related issues that you need to make sure you're testing properly, this is maybe a great way to be like, okay, are we meeting the different benchmarks that we want to meet? So that's really useful to be able to test those different things. Now I want to go back to our testing suite. So we'll just call test right here. We'll minimize this back down. I want to talk about a few important things to understand about the different expect clarifications that you can do. Oftentimes you may have code that is going to be asynchronous that returns to you a promise instead of a value. So let's imagine that this sum function was actually asynchronous. We're just going to return a new promise for the resolve function. Actually, we can just say promise.resolve. That'll return to us a promise for this particular code. And now if we give this a test, you can see everything's failing because it's expecting different values and we're getting a promise instead. The really nice thing is we can just come in here and we can add the .resolves as like a chain afterwards, and then we can put any of our normal assertions afterwards, such as to be and so on. And what this will do is just get the value of whatever this promise resolves to and use that as the thing. So if this is a promise that resolves to the value of 3, it'll wait for the promise to finish, give us that value of 3, and then check that. Now to clean this up, I'm just going to get rid of all these extra tests that we don't need. There we go. Now we'll give this a save, and you can see our test down here is now passing because it's comparing 3 to 3 by waiting for that promise to resolve. We also have the ability to wait for promises to reject. So if we know a promise may fail, we can put rejects in here to get whatever that failure value is to do different tests related to it. Another really important thing that we can do is we have the .not prefix or postfix that we can do, and this just allows us to do the opposite of whatever thing we're doing. So this is saying this does not equal the value of 3. And if I come in here and remove this promise section from here, give these a quick save, you'll see we're failing because obviously this does equal 3. So if we remove that, we'll go back to a passing test. Now, like I said, there's about 1 million different tests that you can do to something, there's a ton of them inside of here. But if you notice that maybe you don't see what you want inside of here and you want to be able to test just against a normal function, for example, you can just say to satisfy, and then you can pass it any function that you want. And this function will take in whatever the value from here is, so v in our case, and then we can just return a true or false value. So if I can say like v is equal to 3, and now if I give that a save, you can see this is passing because v is 3. While if I say like 2, for example, you can see it is failing. So this allows me to essentially create a function that I can run to test against. So if you don't have an exact matcher that you want that fits what you need, you can just throw in a function here to do that matching for you. Now, the next thing I want to talk about is going to be stubbing, mocking, and spying, which is something that if you find yourself using these features, I highly recommend you take a look at your test to see if this is the best way to write your test, because oftentimes these features are not things that you want to use unless you absolutely need to, because they can make your test flakier and harder to work with, but in certain situations you definitely need them. Now I'm going to create a brand new function inside of here. We're just going to call this callback, and it's just going to take in a callback just like that, which is just going to be a function that returns nothing. There we go. And we can just see inside of here, all we're going to do is just call that callback function. So this is to simulate something like if you have a document where you're adding an event listener, you pass along that event listener, and you want to be able to check, was this event listener called? What function or what parameters was it called with? All these different things related to that function that you want to check. This is going to be where this mocking, spying, and so on is going to work. So if you want to be able to create a function that you can pass to another function really easily, that is something you can use the vi dot fn function for. I'll show you what that looks like inside of here. Let's just bring this back to a passing test. So we'll say to b3, there we go. And I just want to copy this down because this is going to be for our basic callback usage. And we're going to test that callback function. We can get rid of these console logs, get rid of that expect, and inside of here, I believe I called this callback. And normally you'd pass it in a function, something like this. There you go. And this will work, but what if I want to make sure that this function was called, or make sure that it was called with particular parameters, or make sure it was only called a couple of times? Well, I have no way to do that inside of here right now. So what I'm going to do is I'm going to come in with that VI utility. I want to create a function specifically, and inside of here, I can just pass it an implementation if I want to. I don't have to pass it an implementation, but we can pass it an implementation like I always want it to return the value 3. That'll make it so it always returns 3, for example. We'll just come in here with no implementation for now though, and that's going to give us a function just like this. We can pass that function along into here to our callback, and you can see that it still works just fine. So essentially what I've done with this is it allows me to create a fake function that I can pass along, and then I can track different data for how that function was used. For example, I can expect my function to have been called, or called a number of times, to be called once, to be called after. I can do a lot of different stuff with it. For example, I can say I expect this to have been called only one time. And now if I give that a save, you can see we have 2 passing tests. But if I go back into here and I call this function twice, you'll now see that my test is failing because I expected it to only be called once, but it was called 2 times instead of just once. So we go ahead and fix this, so at least it's working again. And I really like this because it allows you to just kind of fine tune if you have callbacks and so on to make sure they're working as you expect. And you can make sure that they return placeholder data. That's where I find this most useful. Oftentimes, if maybe you have a function that is doing a lot of really complicated things and you want to make it much simpler, you can use this function to just create a really simple version that returns like a hard-coded number or value like this to just make sure it skips all that complicated stuff that you don't want to have inside of your test. Another really nice thing that you can do is you can come in here and you can actually call a few methods on here. For example, you can say you want to mock the implementation once. That allows you to like redefine what the value of it is. You can also mark the return value as well. So you can say, you know what, for one particular time, I want this to return 4. So it normally returns 5, but the very next time I call it, it's going to return 4 just once. So that way I can really easily be able to say, okay, you know what, I want this to return 4 for this particular use case. It's a great way to just be able to modify these functions and use them like you see fit. Now the next one I want to talk about is spy on. Spy on's a little bit different because instead of creating a new function, you're taking a function that already exists somewhere and you're replacing it with a new value or a new implementation. And this is used on particularly objects. So let's say that I somewhere have an object that is given to me by someone else. And this object has a function, we'll just call it like getPeople or something. There we go. And this getPeople function does something. Let's just say complicated code. And you don't want this complicated code to run. It calls like a database and all these other things. You don't want to have to worry about that. So instead, I'm going to stub this out by using a spy. So I can come in here, I can spy on my object A, and I want to get the getPeople function from it. And then I can add my own implementation to this. So this returns to me a normal function like this. But if I wanted to mock my own implementation, I can just say mock implementation. And now I can just say it's going to return to me an array that has one user with the name of Kyle. So now the next time that I call this fn function, it's always going to return to me an array with the name of Kyle inside of it. Now the important thing to know is this doesn't return to me a function that I can use. It's just essentially spying on this existing function. It's replacing the function inside my A variable here. So now instead of using this function, this is kind of like a spy. And I can call my callback by passing in this A variable right here. And I want to specifically use the getPeople function from it. So I'm passing that function in. Normally it would call this complicated code inside of here, but instead it's going to call my code right here. And I can even test that by saying, you know, I expect the spy to have been called once, and my test right here is still going to pass. I can even come in here and say console.log old code or whatever. And you'll notice when I look through my console logs, I can't even scroll because there's nothing actually logging out. While if inside my mock implementation, I just change this, make this a return statement here, and I come in here and I just console.log mock. There we go. And now I save, you can see it's printing out mock because it's running this version of the code instead of the original version up here. So it allows me to replace what a function was inside of a particular section. Now, when you're writing tests, you have to be careful if you do this because you could be overwriting so much code that your test is entirely different than the real code that's working in your application. So this is why when I have lots of mocks and spies inside my code, I try to be asking myself, do I actually need all these things or am I over engineering my test? And instead I need to remove some of this stuff to make my test simpler or more focused on a particular thing, because if you have too many mocks and so on, it gets really complicated. Your tests become flaky, they become slower and less reliable. Now, the final Vitest feature I want to cover before we start working on how to configure this with things like React and how we can configure this with end-to-end testing is going to be how we deal with timers. Let's say inside of our sum function, we actually put this inside of like a set timeout that's going to run. So we can come in here, we want to return a new promise. We want to have a resolve function. We're going to put this inside of a set timeout, and this set timeout is going to return whatever a plus b is. Make sure that's a function. There we go. It's going to resolve whatever a plus b is at the end of that function. There we go. And we want this to run after like 5 seconds, let's say. Let me make sure I get all my parentheses in the correct location. There we go. So now, instead of returning the value immediately, I have a 5-second delay. And obviously, I don't want to wait 5 seconds to run my test because that's just not very good. So instead, Vitest has a really easy way for you to deal with this. Let's simplify our code quite a bit. We'll get rid of all that callback stuff because all we care about is this sum function. And what we can do is we can add a section for before each because we know we're going to be doing this for any test inside of here because they all involve a timer. And I want to use v.fake timers. So we're going to say use fake timers just like that. And we want to make sure that when we enable fake timers, it's going to enable it forever until we disable it. So we want to make sure that after each one of our tests, we also disable our fake timers. So after each, we want to reset all mocks. What this is going to do is going to reset everything that we faked and mocked. And in our case, it's going to reset our timers back to normal real world timers. So now we have these timers and they're completely fake. They still run normally, but we have a lot of functionality in how we actually deal with these timers. For example, you can see I can advance my timers by a certain amount of time. If I just type in timer, you can see I got a bunch of different things I can do with my timers. And the important thing is I can just run all my timers. What this function is going to do is essentially going to run everything that is currently waiting for a timer. So what I can do is I can come in here, I can say my result is equal to calling sum of 1 and 2. Then I can run all my timers, which is going to wait for that 5-second timer to finish. It's just going to immediately finish it instead of waiting 5 seconds. And then I can expect my result to be 3. But again, since this is a promise, we need to make sure it resolves to the value of 3. Now, if we open up our terminal and we click save, you can see now our tests are passing. Now, you will notice we get a small little warning. Essentially here, it's saying, hey, we are trying to use a promise, but we're not awaiting that promise. Essentially what they're telling you to do is throw an await right inside of here and an async keyword. And that's going to make sure that Vitest always waits for this promise to actually finish properly. That way it doesn't exit out of your test early. Currently, Vitest will do that automatically for you, but in future versions, they're planning on removing that automatic capability. So they just want to make sure you throw in a wait and an async in here to wait for anything that uses a promise. So not just timers. Anytime you have a promise with like a dot resolves, you should make sure you await that. So now I want to dive into doing some more end-to-end testing and how we can get all of this set up with React. And the really nice thing is if you want to do end-to-end testing, Vitest has an experimental browser mode that's built in that allows you to do this end-to-end testing incredibly easily. All we need to do is run the npx vitest init browser, and that's going to set up all the configuration for us. So let's just copy that command. We're going to come into our terminal, we're going to paste that in, and it should be a relatively quick process. First of all, we're using TypeScript, so we'll say that we want TypeScript, and now we can here choose what we want our browser provider to be. This is essentially the environment that is going to run all of our tests for us. I'm going to be using Playwright. It's the default that they recommend you to use and kind of what everything's built on, and Playwright is a quite popular library, so that's why we're going to be choosing that option. Next, we can choose what browsers we want. I'm just going to choose Chromium as the only option, but you can choose more if you want. And then finally, we can choose what framework we're going to be using. In our case, we have React, so we're going to specify that we want to use React. Now we say that we want to install the Playwright browser just so we can make sure everything's installed. That's going to take a little while, so I'll come back once this is done. So it just finished installing everything, took a couple minutes. Depending on your internet speed, it could take more or less time. And you can see, first of all, it added some extra plugin information to my TypeScript for better TypeScript support. And inside of here, we can see that it created an example file for me to look at for everything. Now, if we go ahead and we just open up that example file in this Vitest example, you can see it renders out essentially the most basic test you could possibly render. Also, if you check down here, you can see it added this Vitest browser config, and this just adds additional configuration for Vitest in the browser environment. Now, we may or may not want this to be a separate file, but one thing to note is if you do want it to be a separate file, we want to make sure we merge in this existing config to get all the values from here. Now, in our case, I don't really see a need for this to be a separate file, so I'm just going to copy this browser section. That's the only part that I care about. I'm going to bring that into my test folder here, and I'm just going to paste that down. And as you can see here, we need to make sure we enable it, set that to true, because this is an experimental feature. We set our provider to Playwright because that's what we wanted to use, and we set the instance here to be Chromium again because that's what we decided we want to use for our browser. Now we can just get rid of this config because we don't need it, and in the package.json, you can see it specified running Vitest with this particular config. Again, we can get rid of that because we're just using the boilerplate basic config. So now if I come in here and I run npm run test browser, that's going to run all of our different tests. And when we run that, it'll actually open up this UI. You can see here, it's a really basic UI that has all of your different tests inside of it, and it runs them all inside of this Chromium-based browser. Now, in the case of our sum-based test, it doesn't really make sense to run these in the browser. So I'll show you in a bit how we can set up to run only certain tests in the browser. But if we look at this render name function, we can see if we just play this, you can see what the output of that particular function is, as well as over here, all the related stuff to that test. Right now, this is experimental, so the overall UI here is really basic, but you can at least see all the information we need about all of our tests that are running. And if one of our tests was failing, it would show up over here as a failure. So this allows us to render this essentially inside of a UI, which is really nice for all these different testing related things. If we don't like the UI popping up though, we can come into our configuration. We can disable that by coming into here. We want to say headless mode, set that to true, and that just removes that UI from showing up. So now you can see if I just close this and I reopen it, you'll notice that it doesn't actually open up any type of UI for what's going on in my code. Now, I did mention that I'll show you how you can set up different configurations to be used specifically for the browser versus not the browser. So what we can do inside of our test section here, if I just make this a little bit bigger, is we can create a projects array. So we can say projects like that. That takes in an array. Each one of these is going to take in an object with all of our different configuration settings. In our case, we care about modifying the test section. And inside of here, essentially, I want to create one test that's for the browser and one that's not going to be for the browser. So what I can do inside of here, make sure that comma is placed here, is I want this one to only include the files that are not browser-related files. So the best way for me to do that would actually be with an exclude. And I just want to come in here and I want to say that I want to exclude any file that has a .browser at the very start of it. And then it's going to have a .whatever it's going to be, for example, .test or spec, and in our case it ends in .ts. And exclude expects an array just like that. So essentially what I'm doing is I'm saying ignore anything that starts with .browser at the beginning of the test name. So we can denote our browser-based test by just putting .browser in front of them. Then what I can do is I can just copy this down a second time, and this one's going to be for my browser test. So I can just say I want to include anything that starts with browser at the start of it. I can then give these projects a name, so we can just come in here. We can say that the name for this one is going to be unit test, for example. We can come down here. This one is going to be our browser-based test. And we can also specify what the environment for this is. So we can say environment for this one is going to be Node. Now we don't need to specify the environment for this one down here, but we do want to bring all of our browser-based settings, and we're just going to put them directly inside of here. So now at least we have our two different environments set up. Now we can go ahead and modify our package JSON to only run certain tests. So for our browser test, we can just come in here with our project, and we named that project browser. So we can just say we want to run only our browser-based test. We could also come in here with a test, for example, for our unit test, and that's going to do the exact same thing that we did here, but this one's going to be for our unit-based test instead. So now I have the ability to test just unit test or just my browser-based test, and to test to see if that actually works, we'll come in here and we're going to run those browser tests, give that a quick save, and immediately we can see that it's not finding any test, and that's because I don't have this test named properly. So I'm going to rename this to .browser.test. And now hopefully, if I just restart this, we should see that the test is actually found. Of course, it's not being found because this is a .tsx file. So let me just modify my Vite config here to add in the optionality for this to be a tsx file for both of these. So that just makes it so that X is optional. And now you can see that it is actually running my test. For some reason, it says it's failing because React is not defined. I believe the reason for that is I need to make sure that I extend my test, because right now I have this globals and benchmarks section set up. I just want to make sure that I extend things properly by saying that I want to just put an extends inside of here. There we go. Extends true. That'll just make sure that both of these essentially extend all of my plugins and my globals and benchmark down here. That should hopefully fix. And now, as you can see, we actually do have that passing test. And this is only running any test that starts with that .browser prefix. So now we can come in here, we can look at the actual code for this to understand what's going on. Really, these functions are made up of just a few parts. We have our render function, which we pass in whatever our component is. In our case, we're using React, so we can just pass in a React component. If you're using some other library, you can pass in your own components from that library. That's going to return to us a bunch of different functions. As you can see, we have a ton of different options inside of here. Most of them are going to be related to getting elements based on the text of them, the label of them, the role, or in this case, we also have this test ID section down here. Whoops, I clicked on the wrong one, test ID. And this essentially allows us to grab an element that has a data test ID set to a specific value. Oftentimes I like to use get by text or get by text or get by role instead of this get by test ID, because this just makes my test a little bit flakier because now I have to worry about making sure these IDs are on their correct elements. So if possible, I try to use the other methods whenever I can. Now, whenever you call any of these methods, such as get by text and so on, that is going to return to you something called a locator. If we hover over here, you can see we get this locator being returned. And a locator is just essentially a point inside the DOM where this is pointing to. It's like a DOM element, but it's a little bit fancier than that. And if we want to be able to test things based on a locator, we just use expect.element. Essentially, if I hover over this element, all it does is it's a fancy wrapper for when we're using a locator, because being able to get an element from the DOM may take a while because we have to render that thing to the screen. We have to wait for the document to actually query that element, and then we get that element back. So instead of using a poll to wait for a specific element, we can instead use expect.element and just pass in the locator, and it'll do all of that stuff behind the scenes for us. And the really nice thing about these elements, if we just kind of move this out into a variable, is there's a lot of stuff that we can do with it. We'll come in here like this, and this is technically a locator, so we'll call it LOC, just like that. And if I just come over here, I can type in LOC, and we can see all the different methods on side of here. As you can see, we have a lot of ability to get things from it, just like we did inside of our page in general. So if we want to be able to get children of this element, we can do that. We can also come in here and we can say that we want to specifically get the element or the elements that this points to, which is really great if it's getting multiple elements or a single element. We can get the actual DOM element. So when I say .element, this returns to me essentially the DOM element itself. As you can see, all of my normal DOM related stuff is inside of here. Also, I have the ability, if this is like an input or a button, I can stimulate the click event listener and so on this. So it allows me to do a lot of different stuff inside of the screen for all the different stuff that I want to check, as well as be able to check, for example, different assertions. The really nice thing about this browser mode is it adds additional assertions that we can use. So if we look inside of here, we have the to be in, and that checks, is this thing in the document? And we could also just throw a not in front of there to say it's not inside the document. We can also check the value of this different thing. For example, I can test, is this a valid input? Is it visible on the screen? Is it invalid? I have a lot of different things I can test inside of here. I can also check, is it disabled? So we can say here, is it disabled? I can check the checkbox state. I can even check if it has specific text. So I can say to have text, there we go, and that checks, is it have this text inside of it? So there's a lot of different stuff that we can do on top of the normal assertions that are more DOM related. So let's go ahead and actually write out some basic tests for our counter function, because that's really what I care about. And we'll get rid of all of this extra code that I have inside here. This is like to be in document, there we go. And actually, let's just delete this because we don't even need this Vitest example. It's purely for example purposes. So let's go ahead and we're gonna write this particular function for our counter. Now, first of all, you'll notice I'm using the sum function inside of here. So let's go ahead and fix our sum function to just make it return a plus b. And we'll get rid of this callback function down here because we don't need that. That should clean up all of our code. This test will most likely fail, but I'm not too worried about that because we're focusing on this test right here. Now, to create a test file for this, we're going to call this counter.browser.test.tsx because this is a browser-based test. And I want to do essentially the same stuff I did inside of here with a describe block and a test block. So we can say describe, just like that. And we're going to say counter. And then inside of here, we'll just use test basic counter usage. There we go. You can obviously give these tests much better names, but this is just for example purposes. Now, the first thing we need to do is call that render function to render out what this particular code is. So make sure that we get render. We need to make sure we import that. So at the very top of my page, we're going to import render. We're going to get that from, we want to get from at vitest/browser, just like that. And actually, I'm importing that from the wrong location because this comes from the specific Vitest browser React plugin, essentially the addition onto this to work with React specifically. And we want to render out our counter component. So we'll just make sure we import that and render out that component. So now we have that information on the page and we can just get whatever we want from here. For example, if I want to get an element by text, I can do that. So I can say get by text, just like that. And now if I look inside my counter, I have different buttons with specific text. I have text up here, so I can get like my increment button by using that increment text. So I can say increment button is equal to get by text of increment, just like that. There we go. So now I have my increment button and I could, for example, click that. So I could say that I want to click on that button. And the important thing to note is that anytime that I do an interaction with something, that is going to be asynchronous. So I want to make sure that I await this code. We'll put an async on here. And then once I click on that particular, actually I put the async on the wrong section. There we go. Now, once I click on that button, I should expect my counter to increase in value. So I can come in here with an expect to get that information. So I can say that I want to get my counter value is equal to get by text. And this should say count 0, just like that, because that's what my starting count should be for my counter. So now I have my counter text, I think is what we'll call that. So before I do my click, I can expect my counter text to be in the document. There we go. And then what I can do is I can do the exact same thing down here. I might as well just inline this and inline this here, and I expect the count to be 1 now. So I want to get the text of count 1, and now I expect that to be in the document as well. So now if I save, we should hopefully see this test run, and it looks like we have a little bit of a failure going on inside of here. I'm not 100% sure what happened. It may have just been some weird bug, but as soon as I just resaved my file, everything worked fine. So as you can see, my tests are now passing properly, and if I were to change this count to 2, we can see that my test is failing because it expects the count to be 2, but the count is actually 1, and it actually prints out everything in my document so I can see what it looks like, which is really handy. So as you can see, getting this browser mode set up is actually quite simple, and it's overall not too complicated to work with because for the most part, you're just dealing with this get by text and so on. Now, in my case, I should be putting expect element here because these are elements that I'm expecting to get. So that could have been part of the reason why I was having a problem when I first ran this. Now, if I change this back to a 1 and we just make sure that we await these values because these are also asynchronous. If I hover over this, you can see that this is an asynchronous code that returns to me a promise. Now, if I give that a save, you can see everything is passing. So again, that's one thing that is very easy to forget to do is to make sure you put that expect.element whenever you're getting specific elements that you want to check things on. Now, hopefully this video helps give you a jump start on how to get started with testing inside of Vite with Vitest and even outside of Vite so that you can hopefully start using tests inside of your application, because as soon as you start writing tests, it means you have much more confidence in the code that you write, which means you can push further with your project and start adding new features quicker. Now, if you want to check out all of the code from this project, for example, to look at this Vite config file down here, I'm going to put a link in the description for a GitHub repo that has all of this, so you can go ahead and you can copy this over and use it in your project.